Hey everybody, welcome back to Problem Solver. So yesterday we discussed the limit definition or the difference quotient, which was basically just whoops, bring that down a bit. Limit as h approaches 0 of f of x plus h minus f of x all over h. So that was what we discussed yesterday. Today we will be using this concept in solving this problem, which is from the September 28, 2003 MIT math test. This problem is relatively easy, but if you are not clear on your understanding of algebra, it will be hard. So we're gonna go ahead and solve this, and we'll see how it goes. So begin. Let's write out the limit definition that we have. Limit as h approaches 0. I know I just wrote this, but just in case. Plus h minus f of x all over h. That's our limit definition. And we have f of x equals 1 over x squared. So our f of x plus h must equal 1 over x plus h whole square, right? So then plugging these two in here, we would get limit as h approaches 0, 1 over x plus h whole square minus 1 over x squared all over h. So this is our formula per se, and then we can continue. So what we're going to do now is we're going to get a common denominator on the top so that we can put x squared over here and then x plus x squared over here. So what we're going to do is actually we're going to multiply this side by x plus h whole square, both the top and bottom. And this thing we're going to multiply by x squared, both the top and bottom. Right? So then we get x squared minus x plus h whole square. Always remember that squared is outside of the FOIL. X plus h squared multiplied by x squared because the denominators are equal to each other. So we can put that all in a single equation kind of thing, all over h. So we can just remove the all over h and then put that right over there, just because we already have a common denominator, so we can just put the h in the denominator. So we have x squared minus x plus h whole square. So let's take it to the side for a second and do the x plus h whole square part. Whole square. So this actually becomes x plus h multiplied by x plus h. And then we can use FOIL on this. So x squared plus xh plus 2xh plus h squared. So it's x squared plus 2xh plus h squared. Okay? And we have a subtraction sign here, right over here. So what we're going to do is we are going to incorporate that subtraction sign into this. So it's going to be negative x squared minus 2xh minus h squared. So we're going to have limit of, whoops, my bad. H approaches 0. X squared minus x squared is already 0, so we can just cancel this out. Then we have negative 2xh minus x squared all over h multiplied by x plus h whole square, which we already have over here. So we'll also do the denominator part right now. So we have h multiplied by x plus x whole squared, which is just this, multiplied by x squared. So we have x squared h multiplied by this, which is um, x squared plus 2xh plus x squared. Okay? So it's pretty straightforward. And remember one thing, never ever forget this limit as h approaches 0. I'm pretty sure you'd lose all your points, or at least like a good majority of your points. This question is worth 20 points, by the way, so I'm pretty sure they have some sort of regulation for that. They don't only account for the answer, they also account for work, because it does say show all the work at the end of the day. So we have this, right? Let's get rid of this area so that we can use it for our benefit. Taking some time, but I have it. Okay. And we have that ready. So we have this. So one thing we see common here is that there's an h here and there's an h here, right? So can we remove that h completely? So if we do this, it's h negative 2x minus h. So we just remove the h, so it would be h negative 2x h minus x squared. But removing the h, you do the distributive property, and it's all over x squared h, right? So what I'm going to do with the denominator here is I'm going to multiply this term in. So it's going to be x to the power 4h plus 2x cubed h squared plus x squared h to the power h cubed. X squared h cubed. And yes, never forget the limit as h approaches 0. Okay, limit as h approaches 0. What we're gonna do now is just delete the h out, because we don't even need it anymore. So this becomes 2. So then we have negative 2x minus h all over x to the power of 4 plus 2x cubed h plus x squared h squared. Now we can begin plugging in this h equals 0, because we know that limit is as h approaches 0, right? So on the top we just get negative 2x minus 0, which is just 0. And then we can go to the bottom, x to the power of 4 plus 0 plus 0, because if you plug in h here, 0 here into the h, it will become 0, and this will also become 0. So our total derivative is going to be negative 2x to the power of negative 3. Okay? This is going to be our answer. But really quickly, there is one way that we can figure out whether we are right or wrong. And I know that in the previous lessons, I taught how to do the power rule. So we're going to use the power rule right now to see if this is the right answer for our convenience, and just to check it out, right? So let's use a different color. So we use f of x equals 1 over x squared. We do the quotient rule. It's bottom d top, so that's 0, because the derivative, the constant is 0, minus top d bottom, which is 2x, all over bottom squared, which is x to the power 4, and that is negative 2 over, use that, 2, negative 2x to the power negative. And as we can see that this matches the negative 2x to the power negative 3 that we have over here, so we know we did correctly. And then there's another way we could actually do this. We could also do f prime of x, or f of x is actually equal to x to the power negative 2, because you know the 2, when it comes to the exponent, when the exponent comes to the top, it becomes -2. At prime of x, so we could just use the power rule, so it would be -2x, because this comes back, and we subtract 1, and then this -2 comes back here. So when we subtract 1, we get -2x to the power of -3, and once again, we get the same answer. So there's actually 3 ways to solve this one problem, but we were asked to use the limit definition of the derivative, and that's what we did. Thank you for watching, and subscribe, like, and comment, and I'll post more videos from the MIT practice exams. Have a great day, and I'll see you tomorrow.